Welcome to the 50/50 lab. This is Ms. Drummond speaking. I want to introduce you to the equipment before we start. So right here we have an electronic balance that will measure the mass to the nearest tenth of a gram. And then we have a regular thermometer that measures temperature in degrees Celsius. Each line is a tenth of a degree. So we're going to measure, we can measure to the hundredth of a degree, but we don't really need to be that precise for this lab, so we'll measure to the tenth of a degree. We have some small plastic pipettes for transferring liquids. We have a 50 milliliter graduated cylinder that each line is 1 milliliter of volume, liquid volume, and the little plastic disc is there to protect it if it tips over so it doesn't break. And this is a 100 milliliter graduated cylinder for measuring liquid volume, and each line on this piece of equipment is 1 milliliter of liquid volume. The chemicals we are going to use are ethanol, which is a type of alcohol. It is flammable and it is toxic, and you don't want to get it in your eyes. And some deionized water, which has been filtered. That's what it means to be deionized. So it's pure water, but it has a little bit of food dye in it because ethanol and water are both clear liquids. So we needed some way to distinguish between them. So the water is dyed blue and the ethanol is clear. I'm starting with ethanol and water before they're mixed together, and before I've even layered them together. I'm taking the initial temperature. They've been sitting in the room, so I'm assuming both of their temperatures are about room temperature. It looks like the water is about 25.5 degrees Celsius. I'm going to leave the thermometer in the ethanol right now while I record the temperature. So water was 25.5 degrees. And it's really not changing in the ethanol at all. So I'm going to say that our starting temperature is about room temperature, which is about 25 degrees. So the next thing I'm going to do is measure out 50 milliliters of water in my 100 milliliter graduated cylinder. I am then going to add the ethanol to this graduated cylinder, so I wanted it to have enough volume capacity to hold both liquids. So I'm going to hold the graduated cylinder at a 45-degree angle and very carefully pour some water in. And then I'm going to get down at eye level and look at the bottom of the meniscus, and I can see that it is just a little bit below 50, so I'm going to pipette a little more water in there until the bottom of the meniscus is at 50. So that's ready. The next thing I'm going to do is measure out my 50 milliliters of ethanol. Again, carefully pouring at a 45-degree angle so I don't splash and make a mess. And then I'm very close to the 50 mark, so I'm going to grab my pipette. It's definitely below 50 when I look at eye level, so I'm going to add there we go. Now my ethanol meniscus looks like it is right about at the 50 milliliter line, so I am ready to add the ethanol to the water. I'm going to carefully pour the ethanol into the graduated cylinder containing the water, and I want the ethanol to form a layer on top of the water, and I don't really want them to mix until I'm ready for them to mix. So when I add 50 milliliters of ethanol to 50 milliliters of water, I should end up with 100 milliliters total of my mixture. You can see the ethanol forming a clear layer on top of the dyed water. Letting the ethanol very carefully go down the side of the water's graduated cylinder. So there are a few reasons why the ethanol sits on top of the water. You can at least think of a couple of reasons why that might be. So hopefully you're thinking about that as well. So I have both liquids added together in the graduated cylinder. You can see the water on the bottom and the ethanol laying on top. And I'm going to measure the volume right now while I have them together and write it down before I mix them. It looks like it's right on the 100. So actually it looks like, yeah, it's right on the 100. So I'm going to call that volume before we mix them 100.0 milliliters. And just to see if there's any change in mass after the mixing, I'm just going to put this up here on the balance and get a reading, and I'll do this again after. So 226.8 grams. So I have a reading for mass and for volume before the reaction and temperature as well. I can see that there's a few bubbles, very, very small bubbles, kind of moving around inside of the ethanol. I don't see much for bubbles in the water, and I can see that when I move this graduated cylinder, I can see the interface or the division where the two of them come together, the two liquids, moves a little bit, but they still haven't mixed. Now I need to mix the ethanol and water for 2 minutes. I'm going to use my thermometer for a stirring rod. I'm going to hold the base of the graduated cylinder and I'm going to start the timer for 2 minutes and stir. There are lots of bubbles in there. It's starting to get cloudy, maybe from all the bubbles that are forming. I'm trying to get the two liquids to mix, but I can still see that they're not 100% mixed. It's more cloudy on the bottom of the graduated cylinder and more clear on the top. Just try to get them to mix. The graduated cylinder feels a little bit warm. I'm not sure if that's from my hand or because there's some heat being released here. I'm trying to be careful not to splash anything. Look at all those bubbles in there, rising to the top. Okay, it's definitely looking more clear and more uniform, as if it's mixed completely. You can still see a few bubbles in there, and the timer is off. Stop. Okay, so now it's time to take our measurements. I'm going to measure volume, temperature, and mass again. So I'm going to start with temperature. Just lift it up a little bit so I can see it. I can still see lots of bubbles rising up to the surface from the bottom. Fewer bubbles at the bottom and lots of bubbles at the top. It looks like the temperature has gone up to about 32.1, just over the 32 mark. So I'm going to try to get as much of this liquid off here as I can. Okay, I'm going to take the mass. Okay, it's at 226.7, so very close to what we started with. We started at 226.8, so that hasn't changed very much. And then I am going to measure the volume again, and that looks quite a bit different. So if I read the volume now, wow, it looks like it's well below the 100 mark. It looks like it's about 96. So a significant drop in volume. Strange. So I'm going to show you all the data here on my little table. So to review, before we mixed the two liquids, the ethanol and the water, I took the temperature of them both. They were room temperature, about 25.5 degrees Celsius. I put the whole graduated cylinder with both liquids in it onto the balance, and I got a mass of 226.8 grams. And then I read the volume after I mixed the two liquids or layered the ethanol on top of the water, and I got a total volume of 100 milliliters, which makes sense because I added 50 milliliters of ethanol to 50 milliliters of water. So then, after I stirred them together for about 2 minutes, I took the temperature again, and it had gone up to 32.1 degrees Celsius. I put the whole thing on the balance again and found that the mass was pretty much the same, a difference of about 0.1 of a gram, about 1/10 of a gram. So the mass after was 226.7, but the volume had gone down significantly. It started at 100 and it went down to 96, so it's about a 4% drop in the volume. So that's significant. The drop in mass is very small. It's like very small percentage of the mass, almost non-existent. So there is the before and after data, and I'm curious to see what you have to say about why we saw this dramatic decrease in volume when we mix the two liquids together.